Good morning, guys. It's our second video here that we've done with you. I hope you're still doing well, staying healthy. Not going to take as long as this video today. Last week's video was 20 minutes or so because we had to cover a few things that we have not talked about. We haven't talked about this, but it does go a little bit quicker. It's some things that we are familiar with when it comes to like electrolytes. We kind of know what electrolytes are. And there's Ionics and equations and electrolytes of 6.6. So when we look at this real quick, it talks about electrolytes and non-electrolytes. When you look at the root word of electrolyte, think of electricity. All right, it has to carry a charge. So electrolytes carry charges, non-electrolytes do not. So you see here a non-electrolyte, no current is flowing, you have nothing going from the negative terminal to the positive terminal. When you look at this picture here, we have a weak electrolyte. You're going to see a little bit of current as it flows because those molecules are carrying a charge. And then here, a strong electrolyte. All right, you have an extensive current that is flowing. So with these strong electrolytes, you see the negative to the positive, back and forth, back and forth. You can see it as it goes from the negative terminal of the battery to the positive terminal of the battery. For us, when we think about this, we need to think about in our bodies the sodium-potassium pump that you guys learned in biology. So we talk about the sodium-potassium pump. Sodium is a positive charge. It carries a current. All right? It carries electricity. Potassium, we look at potassium, it's underneath sodium on the periodic table. It also carries a positive one charge. So those two guys are going to give away that electron very easily, so they're going to carry those. Magnesium is a 2+ charge. Calcium is a 2+ charge. When we think about electrolytes, we usually think of Gatorade, or we think of Powerade, we think of when we work out. We need those electrolytes to help our body continue to perform well. All right, so we don't get cramps. So when you think about the sodium-potassium pump, as it's constantly giving off those positive charges. All right, as it's giving those positive charges, negative charges are coming out. Positive charges go in, negative charges come out. And it just continues to go and go and go. It's kind of like a seesaw that just goes up and down all the time. So you see these coming in and out. So when your body gets depleted of salts, which are electrolytes, we have to replenish it with electrolytes from sports drinks. And in those sports drinks, we do see magnesium, we see calcium, we see sodium, and we see potassium. So your body has ridded itself of those, and so that sodium-potassium pump cannot work anymore when you get a cramp, so we have to give it back those salts. That's why it's important if you're an athlete, if you're somebody that's active all the time, doing stuff where you're sweating, that you continue to put those electrolytes in your body. It's important to maybe eat saltier foods, possibly the day before, the day of, that you play a game. All right, the electrolytes are very, very important for us. So we talk about these electrolytes and non-electrolytes. In your notes, it says an electrolyte is a substance that yields ions when it dissolves and dissociates in a solvent and then produces a solution that conducts electrical current. Non-electrolytes are a substance that does not yield ions when dissolved in a solvent and therefore cannot conduct electrical current. So anything that has sugar in it is not going to conduct electrical current. I see sometimes where people eat maybe sugary stuff before a game. That is not any good for you. All right, the saltier, the better. The sugarier, it's not going to do anything for us. Then we have to talk about strength of electrolytes. And this is kind of in here before we've covered acids and bases. We have to be able to know, is it a strong electrolyte, is it a weak electrolyte, or is it a non-electrolyte? You really have to know what strong acids are and strong bases to be able to know what a strong electrolyte is, and we haven't got there yet. We will come back to this when we get to electrolytes, and it's one of our videos that we'll do when we talk about acids and bases. So strong electrolytes are strong acids and strong bases. Something such as maybe hydrochloric acid or sodium hydroxide. Okay. Weak electrolytes are weak acids and weak bases. So a weak acid would be hydrofluoric acid. All right. You also have your weak bases. All right. So weak acids and weak bases are weak electrolytes. And then, of course, you have non-electrolytes, things that are not going to carry that energy. So when we talk about the electrolyte flow chart, is it water soluble? If it's water soluble, it's going to break down. So if it's water soluble, can it break down? Yes, it's probably a strong electrolyte. Ionic? No, I'm probably not going to. So now we get over here to the side. Is it an acid? Yes or no? Is it a strong acid? yes, it's probably going to be a strong electrolyte. If it's not a strong acid, it's going to be weak. It's a weak electrolyte. If we go over here, if we say no, it's not an acid, is it NH3, which is ammonia, or a molecular base? Yes, it's a weak electrolyte. No, it's probably a non-electrolyte. So there's a lot of stuff that goes into it. But like I said, when we cover Unit 7, we go over acids and bases. It'll make this part a little bit easier to understand that flow chart. But we know some strong electrolytes that we use for us, anything that has sodium, potassium, magnesium, or calcium, because they are very, very soluble in water. They're in that aqueous state. They're able to dissolve. So now it gets us into the net ionic. It gets us into what a net ionic equation is. The sodium here, you see, before the reaction, says the sodium, the Na plus, and the nitrate were not involved in the reaction. So you see the before reaction over here, we got sodium chloride. We have two of them, because I see we got our sodiums, we got our chlorines, plus silver nitrate. It says after the reaction, all that's left over is the sodium and the nitrate. All right, these guys are floating after the reaction, but we have a solid that is silver chloride down here at the bottom. And this slide will make more sense once we begin to look at what a spectator ion is. When we talk about spectator ions, they're the ions that are found on both sides of the equation arrow, are not involved in the actual chemical reaction that is occurring. The way I like to refer to this for spectator ions is to say that you're at a game. All right, we go to a ball game. Let's say we go to a big game coming up this fall after this virus is gone. We go to an Alabama-Auburn game in November. There's 100,000 people there. You're a spectator. You really have no part on what happens in the game. It's the people that's on the field that makes it happen. So the spectator ions, you got the spectators on the left, you got spectators on the right. They really make no difference. So we cancel those out, and now the game really takes care of itself, which is kind of what I hope happens in the sports world over the next, couple months, so we can go back to watching sports. Sick of not watching, because the fans, in a sense, really don't matter. Okay? So we look at this right here, writing a net ionic equation. The first thing when we write these ionic equations is it's got to be balanced. Okay, so you've got to have a balanced equation. Now, I'm fixing to do one over here on the board. It's already going to be balanced for you. Then we'll do one more, and that'll be it for your video today. The next thing that we look at, it's not up here. Let's just let's go to the board and let's look at this. Got a couple things you probably need to write down. Go along with it. All right. One thing that I do need you to write down when we talk about electrolytes, and are they soluble? Are they able to be soluble? If it's a solid, obviously, it is not dissolvable. All right, it's not able to be broken down. All right, not able to be broken down. I'll tell you what, we'll make this a little bit easier. A solid, a liquid, or gas can't be broken down in solid. The only thing it can is an aqueous solution. All right, it can be broken down. Okay. When we talk about something as being aqueous, aqueous is just simply something that was soluble inside of a solvent, whatever that solvent may be. That solvent could have been water, it could have been something else. So we're going to be able to break down things that are aqueous. Solids, liquids, and gases will not break down. So in this problem above, calcium chloride is aqueous. We will be able to break it down. Sodium carbonate, aqueous, it will break down. It'll break apart. Calcium carbonate is a solid. It'll stay together. Sodium chloride, in this sense, is an aqueous solution. Okay? So let's do one of these problems. Like I said, we'll do two of them. It won't take us long. You guys will be pretty good with this stuff because it's stuff we've already done all year long. So here, like I said, we break it apart. So simply, you're you're branching off as to what makes this product up. The first thing is a calcium. Like I said, it has to be balanced. So I already had it balanced for you. Got my two NaCl's over there, and we are good to go with this thing being balanced. So, with calcium, we have to determine what the charge of calcium is going to be. Now, for us to know the charge of calcium, we know this 2 tells us that it's a 2 positive. So Ca2 plus chlorine. We break it apart. What is the charge of chlorine? Nothing is written there. Also in group 7 of the periodic table, so it has a -1 charge. Ca2 plus Cl negative is our first part. Now, beside each one of these, it was an aqueous solution, so it is still aqueous. Okay? Plus, now we break these apart. All right, sodium. Now, when I look at sodium here, we have to determine Na2CO3, we have to determine how many of those sodiums did we have. Na2, there is how many? Oh, that's my fault. I need to go back. I know it says that we carried that over, that's the charge, but how many chlorines were there? There were 2 chlorines, okay? Now, sodium, how many sodiums are there? There are 2 sodiums. What is the charge of sodium? It's always in group 1, so it is a +1 charge. Also, carbonate in itself is technically standing alone. Is there anything outside of it? No, so they can go across and tell you that it's a 1+ charge. Alright, so 2Na plus, how many carbonates? There is 1 carbonate, CO3. What is the charge of carbonate? It is a 2 negative. These guys are both also aqueous. Okay? So we have that at this point. That's what we have on the left-hand side. We have broken the reaction side down. Yields. We said a while ago, if it's a solid, it will not break apart. So it stays together. Plus, now we're going to do the same thing here. How many sodiums do we have? We have 2. Has a +1 charge every single time. Plus, how many chlorines? This 2 tells me there are also 2 chlorines. Okay? With A and chlorine always has a -1 charge. Now we have to go back and we have to look at our spectator ions. Okay? What are our spectator ions? Remember, whatever's on the left and whatever equals on the right, those are spectators. They have no part in the game. So, 2Cl -1, 2Cl -1. Spectator ion. Spectator ion. 2Na plus 1. Spectator ion. Spectator ion. Okay? So now for my net ionic equation, calcium 2 plus, there's no calcium 2 plus on the right. Carbonate, there's no carbonate on the left that matches the one on the right. But all we have to do for a net ionic equation is take these 2 things and bring them down, add them together. Ca2 plus was aqueous plus CO3, 2 negative, is an aqueous solution, yields CaCO3 in its solid state. And that would be my net ionic equation for this problem. Let's do one more before I get off here today. So we go NaCl. I'm going to do the first problem that's in your notes that you have to do. Plus lead nitrate, PbNO3 to aqueous solution. Chloride is an aqueous solution. Yields PbCl2, which is our solid, plus NaNO3, which is our aqueous solution. So now we tell ourselves we have to balance this. I'm not going to go through here and balance this with you how we need to do, but you need to balance the equation first every single time. To make this balance, there should be a 2 here, and there should be a 2 here. Alright, so now everything is balanced. The left equals the right. We're good to go. So now, again, we do the same thing. Remember, if it was aqueous, it can break down. If it's a solid, it doesn't. So here, again, this is just like what we did a while ago. 2Na with a +1 charge plus 2 chlorines with a -1 charge. They are aqueous solution. Plus, this guy's aqueous, he's going to break apart. Pb, there's only one of them, but its charge is 2 plus. It's an aqueous solution. Plus NO3, how many NO3s are there? There are 2 NO3s, the charge of nitrate is -1 because it comes across. Yields, PbCl2, again we know this guy is a solid plus 2 NaNO3. The NaNO3 is an aqueous solution, so it will break down. So as it breaks down, it breaks apart. How many sodiums do I have? I have 2. This guy has a +1 charge because sodium always has a +1 charge. How many NO3s? There are 2. 2 NO3, its charge is always -1. We know that because right here, -1. But also you need to remember your polyatomics. So we have broken everything apart. Now we go back and we find the spectator ions, sodium and sodium. Spectator, spectator. Chlorine, no spectator. Lead, no spectator. Nitrate, spectator. Rewrite your net ionic equation. Put your cation first. And that is your net ionic. Lead plus chlorine will yield lead chloride, lead 2 chloride as a solid. If you have any questions on this, we will do another Zoom meeting this weekend or this Wednesday. The Zoom meeting again, we will start it at 8:30. My plan this time is to do only 2 Zoom meetings. I'm going to do one from 8:30 till about 9:15 for chemistry and for physics, so 45 minutes for chemistry and physics, and then from 9:20 until for 45 more minutes I will do my next 2 classes to see if anybody has any questions that goes along with this. Just make sure that you're turning this work in. One thing I will do this week, I will begin to put in grades of things that you have done that you did last week, just because we're beginning to get a little bit more clarification about how grades will work. So if you have any questions, feel free to email me. Feel free to ask me on the Zoom meeting on Wednesday morning, and I will be there ready to answer any of your questions. So, like I said, if you need anything, email me, and I will respond fairly quickly. Thanks.